great pleasure to welcome you all for this event, which is called A Day in Daylight, Light Exposure Around the World. It is part of Daylight Awareness Week 2025. Daylight Awareness Week is an annual event organized by the Daylight Academy that highlights research and practice related to daylight and specifically, thinking about things like the importance of daylight for health, but also broader topics such as urban planning, architecture, and so on. So if you don't know about Daylight Awareness Week, there will be a couple more events this week. And if you also don't know about Daylight Academy, then we'll put links in the chat later on. So it's my great pleasure to be hosting this event today. Again, A Day in Daylight, Light Exposure Around the World. My name, which I should have said maybe to start with, is Manuel Spitschan. I'm a professor at Technical University of Munich and a group leader at the Max Planck Institute for Biological Cybernetics. And I will be hosting this webinar today in the panel discussion along with Resshaya. Resshaya, do you want to quickly introduce yourself?
Hi, I'm Resshaya and I'm a postdoc, one of a member of Manuel's lab, and I'm currently working in TUMCREATE in Singapore, where it's midnight.
No daylight there, unfortunately.
No daylight right now.
But at least you have light exposure in your room by the looks of it. So great. So yeah, we're delighted to have you here, and we're excited to share with you the results of a project that we ran earlier this year that really gets at this question of what is light exposure in humans. And so we'll have the following program. We start with a presentation of the data that we collected by Johannes, who's part of the panelists. And then we have several insights into disciplinary perspectives where we will talk about ultimately why light exposure is important in a given scientific discipline. And we really have a nice spread here from optometry to aging science to visual neuroscience. We have occupational health, we have performance physiology, neurology, circadian and sleep science, and then also architecture. So it's very nice to see this spread of disciplines here, which really brings home the point that measurement of light exposure, understanding light exposure isn't just a sort of niche question in, say, circadian research, but truly is something that touches upon many different scientific fields. Now, before, I'm sure that the panelists will be able to share insights into why light exposure is important mechanistically or for their outcomes. But I just want to motivate us, I think, in thinking about really the importance of light exposure for human health and well-being. We know that there's several effects that are mediated by a pathway that connects the eyes to the circadian clock. We also know that light exposure appears to be involved in visual and ocular development. And so it is something that we, of course, want to understand and study. Here's an example that shows the real-world light exposure of an individual. This is from a data set that Carlyn and Gabriel collected that was analyzed in a software that we'll get to know a little bit better later today, which really shows that light exposure isn't a square wave. It's not off in the night and on during the day, but really depends on where you are, what you're doing, and various other circumstances. And this is something that we want to unpack. There's one thing I forgot to mention, and that is today's event is supported by Marina Roa, who is visually harvesting this discussion. And so she is drawing and illustrating while we are listening to our panelists. And so if you want to see the progress of what she's doing, you can look at actually her camera screen where she is drawing about the insights of what we're talking about. And so take a look there from time to time. And then we'll also have a look at this at the end of the session. So this is real-world light exposure, and so of course any given person will have some particular light exposure throughout the day. And what we were interested in is understanding how does that depend on where you are, what you're doing, and so on. And we already know from first principles that there must be effects of things like location, your occupation, the photoperiod, your climate. But also things related to specific behaviors, culture, and the built environment. And so this is summarized in this graph here, or this diagram here, where really we can see that these things are interacting, and in particular, specific things that might be true in one place might not be true in another place. And so overall, when we're looking at the field, we've come to appreciate that light exposure is not very well understood systematically around the globe. And this is what we wanted to address here in this project, A Day in Daylight. And so how did we do this? On September 22nd of September 2025, which is when the day length is roughly the same across all places on Earth. More than 50 people collected personal light exposure around the globe from dateline to dateline. So from the first minute of the 2nd of September, 22nd of September in any time zone to the last minute of the 22nd of September in any time zone, using chest-worn light loggers that collected melanopic light exposure. And this is truly a unique data set, not only because it's global, but also because it is contemporaneous in time, really trying to show and measure this and characterize this diversity of light exposure that we can see. And so now it's my great pleasure to dive into the data and hand over to Johannes, who has taken on the task of collecting all these data and basically not across the globe, but I guess aggregating all the data, putting them through some analyses, and giving us some insights into what light exposure is really around the world. Before I hand over to him, I just want to thank all the people who were collecting data. I think we had really a strong set of volunteers, many of whom are panelists here, but also folks in the audience, really in many different locations, Costa Rica, in Malaysia, in Singapore, and in Australia. And so we're very excited about sharing this data set. So Johannes, if you are ready, then we're eager to hear from you about the data.
Sure. Thank you, Manuel. Let me quickly share my screen there. And while I do that, and while the screen gets shared, hopefully, let me say hello and welcome to everyone. It's great to be here. I was not a participant, but I was a willing subject to receive what we call a wagon load of data. So I'm part of Manuel's lab at the Technical University of Munich, and today I'm here mostly in my role as a research software engineer, I would say. So we have all these data sets, and I decided, instead of making an analysis where I go through all the different results, what we would do instead is make a dashboard. So people can look at that. And so this is something that we will share after the event. So you will receive a link or towards the end in the chat. So you can have a look for yourself, but I will go through all these different sections of the dashboard to highlight a few of the findings that we have. So this is the dashboard, and it already contains the overview of what we are dealing with. So on this particular day, or a couple of days, I should say, there were data collection points all around the world. So if we sum it up, we have data from 10 time zones, 15 countries, and 47 participants. Actually, we collected data from even more participants, but as is always the case with any kind of data collection, there are some issues with recording devices or some other aspects that don't work out the way you planned. But we still have like a very high number of participants in there, 47 in total, and you can see they're mostly distributed in Europe here, but we have them on the Americas, we have them all the way down to Australia, and maybe for 2026 we will see a lot more red in this map, hopefully so. If we look at the deviation of the time zones that the people who collected the data are in, this is the plot here at the bottom. So every time you see like the number here, this means that this many participants were in this time zone, in this deviation from UTC. And actually, when I plotted up this graph, I thought there was an error in it, because what you can see is there is like this slight shift in all of these cases where the deviation from UTC is larger than you would actually guess based from the time zone map. And actually, it is no error. It's simply daytime or daylight savings that we are seeing here in action. So we have shifted the time zones relative to their actual position on the planet there. So we have most of our participants are 2 hours shifted, but all in all, we have a total of plus 14 and minus 12 hours deviation that we can deal with in theory. And this means that our day that we are looking at is actually not 24 hours, but 50 hours. So the first time point all around the globe where there is some 22nd of September until the last point. So it is quite a while. In terms of the distribution of age and sex, you can see we have a slightly larger amount of females compared to males, and a pretty good spread around different age groups, I would say. So I think that is very good to get a broad understanding. And so the dashboard now has different aspects here that we can go through. I very briefly only want to stay in here because participants were also logging their activities, meaning like where were they, what is the context that they have been in. And on average, people logged around 40 activities between roughly 10 and 80. So every 2 hours, 1.5 hours, someone would open an app, log the current context, whether they were wearing the device, the context they are in. And that would give us a little bit of contextual or auxiliary information to the data set. This allows us to do things, for example, like what we have here, where we can see, okay, based on those log entries, how much time did people spend in bed? Did people spend indoors, but not in bed? We're in kind of a mixed indoor-outdoor condition, where outdoors had non-wear. Actually, this is partly conflicted with the bedtime because some people said not I'm going to bed, but rather logged it as a non-wear time. And then some of the instances didn't have any kind of marker to it. So if we average that across one day, what we can see is that people spend about 6% outdoors. If you count mixed as half of that, we have about 10% of the time that people really spend outside, which I think is very well aligned with what we see in popular literature as some rule of thumb about the time spent outdoors, and the rest is spent indoors in some way or another. Switching to something more interesting here. What we are seeing here is a moving window of the nighttime across the globe. And what we are seeing in those little dots is the melanopic equivalent daylight illuminance. So the effect stimulus of the non-visual system towards light. And what you can see is during the day, everything is very busy. So we are reaching higher levels of light. And then during the evening, it's not as so everything is switching off. We still have artificial lighting, but as soon as we hit probably like the second half of the night, you can see that things settle down pretty nicely. So I think this is like a very nice overview of the dynamic we have across the time of day there. This is a plot that we shared on social media before, and I think it really highlights this complexity that is inherent within the data, that we are collecting data for like several days, but actually we are interested in just one day, and that has two different ways of looking at the data. We can look at local time, and then you have like 24 hours, starting with the 22nd of September, ending with it, or you have this more global viewpoint on that, where all of those things happen concurrently, but not at the same local time. And if we split this up by participants, we end up with something like this, which might look very confusing, but we can go in a little bit closer here to see some context. Basically, what this does is it plots up the different light exposure patterns of participants and relates them to the context they specified or they logged they were in. So everything you see yellow here is logged or marked as indoor time. Everything you see that is green here is mixed time, and everything you see that is blue is logged as outdoor time. And then we have gray as the bad time, and we have red as non-ver time. So those are basically the light exposure patterns overlaid with some kind of auxiliary data. And this is all very complex. This is only actually half of the participants. So we can go to the second half. It looks pretty much the same. You see a lot of yellow. You see regular gray times or red times, depending on how the bad times were logged, and very few mixed times settings here. And this is all well and good, but it only becomes interesting if we really relate this on a more numerical level. And this is actually what will happen here in this tab called contextual exposure. So I'm skipping this one, but let's go to the contextual exposure because I think it is at the heart of this dashboard. So this is a series of tables that basically shows us for different conditions, indoor, outdoor, outdoors, indoors, wear-related screen use or general contexts, shows us how light is distributed in those different contexts. And the starting table here is just in general, outdoors, indoors, or mixed condition. And to walk you through how these tables work is you always have a condition here to the left, and you have a distribution of the light exposure data that is connected to this condition. So you have it visually as a histogram, but you also have some numbers here that show the median, that show basically the different percentiles, so minimum value, maximum value. 95% of the data are between 0 and 37,000 lux melanopic EBI. And so you have the distribution of light exposure, and you can very nicely see how this distribution changes depending on the context, which is something that we really don't have as a whole. So this is some information that we are desperately lacking, I think, in published literature, that we can relate our light exposure data, measured light exposure data, personal data, to real contextual settings. So we can see here that we have like this distribution around, let's say, 50 lux melanopic EDI for the indoors, and then for outdoors it's more towards 1000 lux melanopic EDI. And then for these mixed settings, you can see there is this bimodal distribution that really encompasses both of these different contexts in one context. And then over to the right, we have the timeline. And the timeline shows basically the timing and the intensity and the like how often this condition happens at a given time of day. So what you see here in yellow is when outdoors happens across the day, and compared to that everything else. So you split your data set into two, the condition and everything else, and you can see that the outdoor condition, for example, really isn't that different from the indoor condition at evening, but it is very different during the day. And I think like this will be a very nice thing to dive into. So once you get the chance to look at different contexts, then you can really explore this. There's also the mean value here, the duration of episodes. So like how long was an episode that was logged and how many of them do we have in that category, and what it was the total duration we have. So for example, if we go into the indoor condition here and look at the different contexts that people are in, we can see that there are some marked red, and those are the conditions where we have less than 5% of the overall data in this condition. So there is very few time spent or logged in healthcare settings, but there is a lot of time spent in the home. And so you can really dissect these different lighting conditions. And hopefully this is something you will get into once you have the access to this dashboard. It's also pretty interesting to see at home. I mean, we don't have a lot of light exposure, but obviously that also contains the nighttime light exposure. So we are somewhere at a level of around 100 lux melanopic EDI, slightly below that during the day. So I think that is like a very very rich data set. We could, dissect and dive into this, talk about when people use the bathroom or at least log it. But all of these things are things that I think you will go into. I want to finish off this with a little challenge run. I call it the run for the sun. And so this is something you've seen before on the global light exposure to the left. But on the right here is another section that tells us basically the light dose, the cumulative light dose that people got during those 48 hours of the 22nd of September. And we can see it is already coming in, and we have a very strong start from Madrid and also the US. And as there is nighttime now in Madrid, the US really can move forward and have like a higher light dose. But as nighttime creeps over the Americas, the European countries can move forward a little bit. So let's see who overtakes who. And let's see who is the winner of the run of the sun here. So really, this is just the light dose, the cumulative dose of light that people have experienced during those days. And we can see that Madrid is really pulling forward. We have to see whether whether Costa Rica can pull ahead here. It is, there is still time. And nighttime falls, and sadly, it just didn't work out that way. So in the end, now that there is still more morning already in Europe again, we'll see additional light exposure there. But there will be a few things changing in the places above the first place here. And it looks like we have a winner here. So the winner of the run to the sun, we have it here. It is Spain for 2025, but there are many very commendable light exposure patterns in the other countries here. And let's see who wins the challenge next year. So just a very quick view into the light exposure patterns across the globe. There is many more analyses you can find here. And because we support open and reproducible science, there is also an analysis script. So if you want to receive all those results for yourself, go ahead, you can do that and analyze these data for yourself. So thank you very much. Over to you, Manuel, or to the other panelists.
I can take over. Thank you so much, Johannes. It's really nice to see these data and have them actually discoverable through the dashboard that you have built. I think it's really, really powerful, I think, to bring these data to life. We have potentially a little bit of time for questions. There was a couple in the Q&A. I'll just go through them. There's one attendee who asked what non-wear means, and I had responded in writing. I'll just repeat this. It basically means that the participants were not wearing the logger, or at least were reporting that they were not wearing the logger. So this is, of course, the time that we would not want to trust these data because the loggers are sitting on some desk somewhere. We had one comment about lack of representation from specific parts of the world. We tried to get as many people on board, but our efforts are finite, and so unfortunately, if we couldn't find volunteers, then we couldn't unfortunately collect the data there. But and this connects to another question: will there be future editions? Johannes already said next year, so I think maybe this could become an annual event, so I think we're for sure interested in seeing how this develops. But yeah, in general, I think we would love to have as much representation as possible. And I think we've made a really good start here. But of course, I think it would be good to expand to even more countries that we can. Now, if there's any further questions from the audience about the dashboard, you can also raise your hand and I can ask to unmute yourself. Otherwise, you can pop the questions in the Q&A.
About questions, I can also just talk a little bit more about that. Obviously, what we are doing here and what we are talking here is very different from a traditional study where you try to not influence people about changing their light exposure behavior. just by making this out as a contest, I mean, we didn't beforehand, so, I think it's fair game here. But if we set out and say, like, this is a goal or that is a goal, obviously that will change how people expose themselves to light. And I think like that is a very important question to ask in any study collecting these data, like, are you affecting people? So.
Great. One question, can you differentiate between electric versus daylight?
So, I mean, using the contextual data, yes, we asked that question, whether the light was switched on, whether there were any kind of daylighting conditions. So just by pulling in the auxiliary or contextual data, we can do that. I mean, there are also some ways you can do that data-driven, but obviously that depends on the on the channels that you have on your wearable device. So here it is relatively rich, so we could do something like that, looking at correlated color temperature, but it will also be not perfect. That you have to be, there is no perfect way to distinguish that. So it's always good to have multiple sources to confirm that, for example, asking people.
Great. There's a couple of questions I'll just respond to in writing, but one question from Kieran Garrettson was, how did you find the participants? This was an open call we put on LinkedIn, and we also tried to contact people using light loggers. And, of course, we only were able to work with the ones who got back to us. But of course, now with this event, maybe there will be a broader base of people who are interested in it. The light logger that was used specifically here, but it's not, I mean, it's a general, any light logger that measures melanopic light exposure would have been qualifying. We used the Agbeshie light loggers. And then I think the other questions, I think we will leave for later. I can try to respond in the chat while writing. And now I'm happy to, so thank you again, Johannes. I think really nice, I'd say data-driven, data-heavy, data-rich presentation of this phenomenon of light exposure. And also, of course, also thanks to everyone who contributed to these data. And that's my great pleasure to hand over to my co-host, Resshaya, who will lead the introduction of our panelists and their views on why light exposure is relevant in their discipline. So Resshaya, you can take it away.
Thank you, Manuel. So let's kick off our session with our wonderful panelists, who are, in fact, our very own A Day in Daylight participants, and they will be sharing with us their unique disciplinary perspectives on light exposure. And to start, it is my pleasure and privilege to introduce our first speaker and my colleague, Lucien Bickerstaff from the Max Planck Institute and the Technical University of Munich, Germany, who will be sharing his insights into visual neuroscience.
Great, thank you, Resshaya, for the wonderful introduction. I hope we can all see the screen. So I'll kick things off. So yeah, welcome everyone. I am Lucien Bickerstaff. I'm very excited to be a panelist, and I'll be sharing some insights about light exposure and light exposure measurements in my field, which is vision science. So I thought I would initially give a short introduction about myself. So I am a PhD student in vision science, and the core of my work is focused around light sensitivity, sensory responses to light, visual discomfort. So I have a background in biology and biomedical engineering, which I did in France, and I am now based in Tübingen, Germany, in Manuel's lab. And when I think about light in my work, I really see it as a regulator of life on Earth. So we know that obviously light regulates a lot about how animals and humans function on this planet, and is obviously a very powerful stimulus for living organisms. So obviously from a biological perspective, it is very relevant for us to measure light to understand exactly what it does and how it does to us. So As part of my work, I am also obviously studying the effects of light in laboratory conditions. So very controlled conditions, as you can see here on the right. You have my colleague Josef exposing himself to light in an integrating sphere. And with this kind of setup, we can also, we can look into specific aspects or specific research questions, which can be a very powerful way to study the effects of light on us humans. But obviously, when we talk about sensory responses, obviously they happen also and mainly in the real world. And in that regard, it is very relevant to also, have a way to monitor these responses where they actually happen, which is in the real world. So this is where the light exposure measurement comes into play. And some of you might be familiar with this reflex of this phenomenon, but light can even make some of us sneeze. And this is called the photic sneeze reflex or a CHU syndrome. So this opens a window into some of the mechanisms underlying some aspects of light sensitivity. And actually, 3 years ago, I collected data myself, which is now published as a case study, where I wore a light logger at the chest level, and I logged all of my photic sneezes because I am a fellow photic sneezer. And basically here, the data shows that before a sneeze, we see an increase in light levels. After, the light levels go back down, and the range at which the light level increases when the sneeze happens is very variable. But on average, we see that it's around tenfold. So obviously, this is some very interesting and insightful information that we gain with monitoring light exposure in the real world. Right. So sharing some aspects of my participation in this day in daylight event. So as a researcher in this field, it's vision science. Obviously, I am familiar with running such studies, but I was less familiar with participating in them. And I figured out it was actually less straightforward than I thought it would be. And, thinking about when to log and how to log wasn't so straightforward, as I said. And talking to my colleagues who also participated, I noticed there were a lot of differences in what would be considered a meaningful change or an accurate way of participating in such studies. So my takeaway in that case as a researcher is that I now appreciate more what it means to participate and how complex it can be. So if we kind of tie everything back together now, obviously, as I mentioned, personal light exposure or measuring personal light exposure offers invaluable insights in some of the aspects of, the effects of light on humans, and some of which laboratory approaches on their own cannot deliver. And obviously, I'm not saying we should use one or the other, but we should use them together because obviously they allow to gain comprehensive, applicable knowledge. So that's kind of my take-home message. I'd like to thank you for listening to what I had to say. You can also learn more about our lab and connect with me on LinkedIn. And talking of photic sneezing, you can also share your photic sneezing experience by scanning this QR code here, and you will join obviously a survey link that you can fill out to share your experience with photic sneezing. With that, yes, I'd like to thank you for listening to me and looking forward to what the other panelists have to say. Thank you.
Thank you, Lucien. That was a really interesting talk. I'm really interested to see what happens with the photic sneeze registry. I think that's really interesting. So now, moving on to our next panelist, I'd like to welcome Carlyn Patterson Gentile from the Children's Hospital of Philadelphia, USA, who will be providing us with insight into the field of neurology.
Thank you so much. It's such a pleasure to be here. I don't have slides, so don't worry if you are not seeing anything but me talking. So yes, I am an assistant professor of neurology and pediatrics at the University of Pennsylvania and the Children's Hospital of Philadelphia in the United States. And here I'm a physician scientist with clinical expertise in child neurology, headache medicine, as well as traumatic brain injury. And my clinical background, coupled with having a PhD in vision neuroscience, has led me to study visual symptoms, including light sensitivity and migraine and post-traumatic headache. in both children and adolescents. This work has recently expanded to include studies that measure everyday light exposure habits in these clinical populations. And because of this, I was really thrilled at the opportunity to participate in a day in daylight to explore how light exposure patterns vary across the globe. Within the discipline of neurology, light exposure is really important because it does play, as has been mentioned, a critical role in setting the timing of a myriad of circadian biological processes important for brain health. So we know that studies have shown reduced daylight exposure and increased exposure to artificial light at night have been linked to disruptions in sleep, as well as disruptions in natural circadian fluctuations in heart rate, blood pressure, and metabolism, among others. And increased daylight exposure, as well as reduced artificial nightlight exposure, have been associated with decreased risk in heart attack and stroke, both important in brain health, as well as lower all-cause mortality. Light exposure also plays a particular role in impacting neurological diseases. So studies have actually shown that timed bright light exposure can be used to treat sleep and circadian dysfunction in neurodegenerative conditions like Alzheimer's disease. Low sunlight exposure has been associated with an increased risk of developing demyelinating conditions like multiple sclerosis. This relationship is thought to be because of effects of UV light on vitamin D production and immunomodulation. And the importance of light exposure really raises a critical issue in neurological conditions like migraine and traumatic brain injury, where light sensitivity is a common symptom that can make being in intense visual environments very uncomfortable. So currently, we really don't have the evidence needed for me to be able to tell my patients whether they should avoid light that is bothersome to them to just reduce that discomfort, or if this could potentially have detrimental effects over the long term. So specifically, it's unclear if photophobia-driven light avoidance leads to physiologically meaningful reductions in daylight exposure that could impact the circadian rhythm. But it's also possible that light sensitivity would have a protective effect on the circadian rhythm by reducing artificial light exposure at night. And since the brain tends to adapt to the environment it's in, it's possible that restricting the intensity of daily light exposure reduces light tolerance that could worsen light sensitivity over time. These questions remain unanswered, and addressing them is critical for healthcare providers so that we're able to help guide our patients on how to best manage light sensitivity, which can really significantly impact daily function. And there's really a lot of cool things that we've learned from a day in daylight. I think that studies like this will help us understand how light exposure varies across geographic region, latitude, weather, urban versus rural settings, as well as across different cultures and societies. And this is really critical to interpreting light exposure findings within clinical populations. I also just want to acknowledge that this is really an incredible global multidisciplinary collaborative effort that has just produced this really unparalleled data set that Johanna shared with us and is allowing us to visualize light exposure patterns around the world. On a personal level, I would say participating in this study, as well as studying the intersection between light exposure and health in general, has really made me much more aware of my own daily light exposure habits, as well as those of my family. So now I really try finding ways of getting outdoor light exposure, as well as reducing artificial light exposure at night. And I think of my daily light exposure habits like I think about exercise or a healthy diet. It's really starting to be integrated into my daily health routine. All that being said, the study of everyday light exposure in clinical populations is really still in its infancy, and there's a lot we have to learn about the scope and magnitude of the impact of light exposure on brain health. And this is an exciting time because the technological advances in wearable light dosimeters make these studies possible. I think it's also going to be really important to determine how light exposure interacts with other factors that are important for health maintenance, like physical activity or stress management. And I think by not including light exposure, we may be missing a key biological variable that impacts health. From a health policy perspective, this could also have implications because if we may find that access to safe outdoor spaces, as well as limited light pollution at night, have important implications for health equity. So to conclude, light exposure, like physical activity or a healthy diet, should be explored as a factor that could potentially be modified to improve brain health, though a lot of work is still needed. Everyday light exposure has the potential to be developed as a therapeutic target, giving us a new tool to shift treatment from reactive disease-based care to proactive preventive care and health maintenance. So thank you, and great to be a part of this panel.
Thank you so much, Carlyn. I think a lot of what you said resonated with most of the participants in A Day in Daylight. I think that I felt like I became more intentional, or I was actually really embarrassed about how little, like how I was actually practicing my light behaviors. And I think this was a great experience. So I just want to take a minute for all of us to also not forget that Marina is drawing and illustrating such a beautiful canvas is appearing like in her little grid. And if you want to take some time to go through what she's doing, I can't wait to see what this ends up looking at the end of today's session. It looks so good. So now let's move on to our next panelist, Gabriel Kwaku Agbeshie, from the Kwame Nkrumah University of Science and Technology, Ghana, who will be giving insight into optometry. So take it away, Gabriel.
Thank you, Share. So I would quickly share my screen with you all. Okay, so thank you so much, Prof. Manuel, for the opportunity to join as a panelist on this day, a day in daylight. So I will talk briefly on light and myopia. I'm Gabriel Kwaku Agbeshie, and currently I'm a research assistant in Dr. Kwejo Sukufu in Ghana, Kwame Nkrumah University of Science and Technology. And this picture of myself in the Actilumus on the 22nd September, the Equinox Daylight Collection. So light is an everyday contributing factor in my clinical practice as an optometrist, where it aids a lot in our clinical diagnosis of ocular conditions, from the anterior segment of the eye to the posterior aspect of the eye. And with our optical devices or diagnostic devices like the OCT, VFT, the retinoscope, we every day, utilize light, and it is an enabling factor in our disease diagnosis. So before I would join this day in daylight data collection, my experience with the Melodious project really, inspired me a lot, and my growing interest in the light spectra and then myopia progression has also been a form of motivation in participating in the day in daylight. And I'm happy to see how light becomes a modifiable factor in myopia control and its prevention. So about the eye, the light we are always exposed to as from birth. As we age, the eye goes through a process of development, what we call metropization, and we expect the ocular powers of the individual ocular structures to harmonize with the eye focal length or the power of the eyes. However, in certain situations, when we are not exposed to the right amount of light, or with some factors coming in play, we don't experience this kind of normal vision, but experience several ocular refractive errors, where I would speak much on more about myopia. So with myopia, light coming from afar does not focus on the retina, but we usually see this light focusing before the retina, causing distance blurry vision. And we know this process that light always excites the melanopsin from the intrinsically sensitive retinal photoreceptors, which is also connected to the imipine, the dopamine humankind in its release of dopamine. And this process is also part of the metricization mechanism of the eye of a normal vision. So about this data collection, we still utilize the Actilumus, and most often, from my personal experience, I'm always exposed to indoor light because of the nature of my work, always in the office, spending much time behind the screen. However, during this data collection period, there were some variance in the light exposure where I expected much light exposure during the day, seeing sunlight. It was, however, some way cloudy during this period of data collection. So some challenges and opportunities about light measurements. It is very, very important and key to us for us to understand the amount of illuminance and the melanopic EDI, how much we are exposed to, as this also contributes to the ocular growth or the eye development. While several light loggers have been developed and capture illuminance and several patterns of light, the Actimus lacked the ability in measuring the spectral power distribution of light, which is also key for us to understand which wavelength is a contributing factor or affects the development of the eye most. And understanding the spectral composition of the lights and their effects in myopia would enable us to translate this finding into filters as part of our spectacles that could aid in the myopia, aid in the reduction of myopia progression among children specifically. So we have the visual environment evaluation tool, which is a very novel and very promising in the measuring of near working distance and then the amount of illumination. Understanding not only the outdoor activity or the amount of time we spent outside, but also understanding the distance at which we experience near work, say reading, writing, could also serve as a contributing factor in dealing with the progression of myopia among children. So my take-home message, we should, optimize, we should utilize daylight exposure in our everyday life and in our built-in structures, schools, and then homes. And then as optometrists, I would also say that we should consider light exposure history when it comes to the assessment of myopia in our various practice places. Thank you.
Thank you so much, Gabriel, for that insightful talk. Next, I would like to invite Hannah Sophie Heinrich, who is also my colleague, from the Technical University of Munich, Germany, who will be sharing insights into circadian and sleep science.
Yes, thank you for the introduction, Resshaya. Do you see my screen?
Yeah, we're actually
Should
seeing
we...
the view.
Sorry?
We're seeing the presenter's view.
Ah, okay, let me see. Ah, no, should be better now.
Perfect.
Awesome. Yeah, thank you. Yeah, thanks for hosting and yeah, letting me talk about the circadian perspective. Yeah, circadian perspective and perspective of sleep science. As you said, I'm your colleague. I'm in Manuel Spitschan's lab. I'm doing my PhD in circadian and visual neuroscience with a background in psychology and cognitive affective neuroscience. And my research is very much focused on the circadian rhythm. So how the human biological clock governs our behavior, our hormone secretion, sleep-wake rhythm, and metabolism. So very mechanistic focus. And what made me want to participate in this project is that light plays a key role in regulating the circadian rhythm. It's the most powerful Zeitgeber for the circadian rhythm. So it does much more than just enabling us to see our surrounding. Yeah, naturally, I was interested in what kind of light diet we have around the world. So from a chronobiological perspective, light is super important because not everyone actually has a 24-hour circadian rhythm. Some people have a shorter internal rhythm and some people have a longer internal rhythm. But in the end, we all got to adhere to a 24-hour day. So light at the right time can delay our internal timing or advance our internal timing, essentially changing the duration of our rhythm and helping us, feel sleepy, feel awake, feel focused or relaxed when we need to. But light at the wrong timing can also lead to misalignment of our internal rhythm with the external environment. So from an experimentalist perspective, I have a very strong motivation in controlling light behavior. So when I'm doing laboratory studies, participants have to adhere to a very specific light-dark cycle. I'm controlling their light environment in the laboratory to very dim light to really avoid unintentional changes to the circadian rhythm. So going into this, this day and daylight, the data collection, I was really interested in, how light exposure in the field would look like. I collected my data in Germany, Tübingen. And as the other panelists already said, logging your own light behavior and being aware that you have a light logger on yourself makes you aware of your light diet. And I think even within the first hour, it made me so aware that there could be such vastly different light scenarios. So even between waking up and going to work, like just approximately 1 hour, it really depends on your decisions, what kind of light exposure you have. Like, are you opening, are you sleeping with shades open or shades closed? Are you going by bus to work? Are you walking? Yeah, all of this really affects our light exposure. And shamefully, I have to admit that I noticed that a lot of my light diet is consumed kind of indoors. So I don't really think I spent a lot of time outdoors, at least not that day. I think that quite interesting consideration also from an experimentalist perspective was that when people are in the laboratory with me, I'm in control in their light exposure. And I kind of just assumed that in field, they are in control of their light exposure, but that's not the case. I realized that a lot of the times our light exposure is determined externally. It's the bus driver deciding what light there is in the bus. It's the office building that predetermines lighting in the office. It's your family, your partner, or your flat share that determines or switches on the light or switches it off. But really relating to the realization that I at least spent a lot of time indoors, and lots of other people, I think specifically working in offices, do too. It's not surprising that it's really hard for us to meet the recommendations of kind of good, or the recommended light levels as indicated by the red line. Manuel showed this graph before. So it turns out that during day, there's plenty of daylight available, as seen from the blue shading, but we oftentimes don't really meet the recommended light levels, while in the evenings, when daylight is already gone, we kind of exceed the recommended level. And the visual system is adapted to help us see. and it's not adapted to give us kind of an indication of what our biological clock needs. So it makes sense that we're really bad at kind of estimating what our biological clock needs. So I think light measurements and immediately feedbacking also our light exposure could have like a huge potential in supporting our circadian and sleep health. So I think my main takeaway is that setting your inner clock to align with your environment using daylight or light in general requires a conscious decision or maybe even guided behavior. Yeah, thanks.
Thanks, and 100%. I think that your takeaway message is it. And now I'm very happy to introduce our next speaker and my colleague right here from Singapore. Our next speaker, Zahrah Alkaff from TUMCREATE Singapore, will be speaking about aging and the role of light. Take it away, Zahrah.
Okay. Hi, good evening. I am Zahrah and from TUMCREATE Singapore and TUM. And with my team in Singapore, we look at light exposure and aging and how we can use it to support healthy aging in Singapore. So to kick it off, I would like to set the environmental context that is Singapore. So we are one of the fastest aging societies in the world, and we lie almost exactly on the equator. So that means that we nearly have 12 hours of daylight all year round, as you can see in the table and chart here. So daylight is bright, consistent, and abundant, but it's underutilized. And why is that so? It's hot, humid, and heavily urbanized. People spend most of their time indoors, which is kind of the paradox of Singapore's daylight environment, where we are constantly surrounded by light, but we are rarely in it. So just a quick background on why light exposure matters. It's a biological regulator for our internal clock, and hence getting enough light at the right time is important. And within the context of aging specifically, older adults are susceptible to suboptimal light exposure due to ocular changes, causing less light reaching the back of the eye. Their sleep and circadian systems also start weakening, and of course, changes in lifestyle due to reduced mobility and just spending time indoors, meaning that they are exposed to less light. And all of this, so light is a key environmental factor, not just for health, but in this context for healthy aging. So the good news is that it is a modifiable health factor, and previous studies have shown methods like light therapy and time light exposure showing improvements. So for a rapidly aging population like Singapore, optimizing light can provide a simple preventative pathway for healthy aging. So what we are doing here, we know the benefits of optimizing light. Looking beyond biology, we consider our daily environments and choices. And in that manner, we can tap into behavior modification. Light exposure is an everyday behavior. When we go outside, where we spend time, how much daylight reaches us, which I think we can all relate to our experience in daylight. And we can also tap into digital health tools that can intersect with behavior change to provide a way that is accessible, engaging, and scalable. And putting all these ingredients in a blender is kind of the work we are doing here in Singapore with the lifestyle-based health promotion strategy to optimize light exposure via feedback. So talking about my experience in the daylight, I think it takes commitment to wear the light logger and log your activities. I think it gave me a deeper appreciation for my participants, my older adult participants who are wearing these devices every day for about 4 months. Personally, it made me more aware of how light changes across different spaces. Even in bright Singapore, I think my exposure was pretty low because I was mostly indoors. And I think just logging light actually makes you, or at least makes me more reflective and intentional. And you realize how invisible your relationship is with the light and how much of where you are and what you do determines your exposure. And I think this is where feedback can actually turn this awareness into action and can be meaningful. So all in all, measuring light exposure is important, gives us a glimpse into how people experience light, particularly with wearable sensors. We can track personal light exposure continuously in real-world settings, which can reveal daily and environmental patterns that can be linked to health metrics. And it also opens the door for feedback when we convert this data into like simple visualizations that people can understand. But of course, there are challenges, particularly within the context of the older adults studies. A lot of them are not particularly fond of wearing like a lanyard, like logger, due to aesthetics and comfort. And I think this might not be the most practical solution for like large populations or long-term use. So the burden is kind of on us to think about ways to make this more scalable, more natural, whether it's through a smarter, prettier design or through maybe digital tools that provide feedback for education and behavior change. And also, we cannot ignore cultural context. Light behavior is shaped through social norms and climate. In regions like Singapore, people tend to avoid bright light for comfort. Maybe in colder countries, it's something that is sought actively. And I think we need to recognize these nuance when considering interventions for demographics. Final reflections, I think measuring light and connecting it with behavior and culture can create sustainable, healthy light practices. And a small shift in awareness and lifestyle can have a big impact on how we age, how we feel, and how we live. Thank you.
Thank you, Zahrah. I think it's really interesting because this pretty much speaks to what Carlyn mentioned about how important it is for us to, have a move from treating to prevention and health promotion. So I think we're all working towards the same goal here on some level, and I think that's really beautiful. So moving on, it's my pleasure to introduce Erin Flynn Evans from NASA USA, who'll be sharing her insights into performance physiology.
Yes, thank you so much for inviting me, and I really enjoyed participating in the Day in Daylight exercise. I don't have slides either, so I will hopefully be engaging enough to make this interesting. But my name is Dr. Erin Flynn Evans. I lead the Fatigue Countermeasures Laboratory at NASA Ames Research Center, which is in the Bay Area in California. And my team studies astronauts, but also pilots and other people working on NASA missions or in high stress occupations who have to maintain a high level of alertness and performance despite not always getting enough sleep or possibly having to work 24 hours a day in very unusual conditions. We develop countermeasures to support these groups, and we often use light as a countermeasure either through guiding the individuals that we support on when to seek light exposure or when to avoid light exposure to help with circadian phase shifting, for example, or for acute alerting effects. And I can say, like, I joined this experiment because I was really excited about the possibility of just contributing to our larger understanding of how people's patterns of light exposure will vary just across the day and as they're going about their daily activities. In my discipline, light matters because we know, that it has both the acute and circadian phase shifting effects. And again, the populations that I study often have very, very unusual patterns of light exposure. So if we just take the astronauts who are living and working on the International Space Station as a first example, they're orbiting the Earth every 90 minutes, which means they have about 45 minutes of exposure to natural sunlight and then 45 minutes of darkness as they go around the Earth. We all know that that is not the type of photoperiod that any human can adapt to. And so we have to utilize light inside the space station to sort of combat that natural photoperiodic exposure that they get from going around the Earth. when we go to the moon, hopefully in 2027, or we'll be going around the moon next year, but when we go to the surface of the moon in 2027, the astronauts will likely be bathed in constant light that's 30% brighter than the light that we experience here on Earth because of the differences in our atmosphere. And so we have to think about these really unusual challenges, but it doesn't stop there because we also study airline pilots. And I think a lot of us think about the effects that we experience when we're jet lagged, when we travel across time zones. We think about how we need to use light to adapt to those time zones. There's obviously a huge body of literature in this area that's really well established. But pilots are a little bit different because they're typically not spending a whole lot of time in the time zone that they're traveling to. So often we may not want them to adapt to that time zone, but given issues like just the social atmosphere, they may need to sleep at times when people sleep on local time, but that means that they may be exposed to light at exactly the wrong time in order to get back on that plane and fly us safely back to our destination. And so these challenges are incredibly complicated. And I think almost every situation that we deal with is unique. And again, while we have a lot of amazing research from so many people probably in this group and who are attending this panel that we can rely on, I think there's so much more to learn. And we need to account for all of these various factors in the countermeasure plans that we give to these individuals. So just switching gears to what I learned about light exposure and behavior during this campaign, my data may have been thrown out because I was on a flight from San Francisco to Zurich from the 21st to the 22nd. And so I experienced a very unusual pattern of light exposure, very much like what the populations I study experience. And I think this, for me personally, was a really good thing because it allowed me to really think about how the pilots that we study are constantly traveling around the world and experiencing these very unusual patterns of light exposure. And so I collected data through the whole flight, which was a red eye, and then through the first day arriving in Switzerland, where I was working with Swiss International Airlines. So I went straight from the flight to an office environment, but because it's Switzerland, we did a lot of walking around. So I was in and out a lot. And it was a very rainy time in Switzerland, which was also very interesting to think about. When I reflect on just that experience and the things that I need to think about in the future, the aircraft that I was on had, they didn't have the up and down shades that some of the older aircraft had. They had these dimmable windows, and the crew dimmed the windows so that we were shielded from light through much of the flight. And then they illuminated the lights as we landed, which actually probably sent me to the wrong time zone when it comes to circadian phase shifting and what I needed to do to adapt. So that was really interesting. The other thing that I thought about was just with the way that we collect light exposure, I think we really need to continue to have development in devices that are, very robust in the way that they, collect the information that we need to assess someone's actual exposure to light. Because again, I was in Switzerland on a very rainy day, and while it didn't seem to be particularly bright from my perspective, I know from studying light that I was outside and exposed to quite a bit more light than I would have been had I been inside for a lot of that time. So I think that we need to just mature some of these devices beyond what we have. To echo some of what some of my fellow panelists said, I think aesthetics are really important in talking with pilots and astronauts. They're not going to wear something that's not comfortable or that looks weird. And so we really need, I think as scientists, we're just thinking about getting the best quality data. But in order to scale these data collections, we really need to think about the individual and what they need to be able to wear these regularly to give us the data that we need. So I guess just to wrap up and share my takeaway. I first was just thrilled to participate in this. Thank you for doing it. I really hope that you continue to do more of these types of data collections in the future. I certainly would be happy to participate, particularly under my normal daily routine. And I think that this type of data will be just invaluable in helping us baseline how people experience light in their daily routines. I think we don't really have a lot of great information at the global scale on how all of the factors that have already been mentioned related to, culture and the photo period and things like daylight saving time affect people's experience with light. And so I'm really excited about this project and look forward to the future and what it will bring.
Thank you so much, Erin, for that really great talk. Next, I'd like to invite Broszio, who is from the Federal Institute for Occupational Safety and Health, Germany, and who'll be giving us insight into occupational health.
Thanks for the introduction, Rica. As you mentioned, my name is Broszio. I got a PhD in lighting technology, focusing on non-visual effects of light from TU Berlin. I'm now based in Dortmund, in the western part of Germany, so at the edge of the Middle European time zone. And here we study how non-visual effects of light influence on the workforce, in context of occupational safety and health. And I joined this global effort because collecting such a global data set that's free from the influence of photoperiod length, and it's more fine-grained in terms of task detail, like we did it in Melidos, for example, which was mentioned as well before, would be interesting. And also we could discover climate-related or cultural-related differences in light exposure, as mentioned before. And I guess the data collection might be a little bit biased because we got a lot of motivated participants and they are aware of light and that their behavior influences on their light exposure. So I guess we need more data, of course. But at least, for Germany, we had in total, I guess, 17 participants or 18, so it's quite good. So why we are interested in light exposure in occupational safety and health? Around 80 to 90% of European employees are working indoors, and we have seen this graph before. Usually they get less light than recommended in daytime and more light in the evening as recommended. And this all has the influences already mentioned on different aspects. And on the other hand, there are about 13 to 25% of the workers in Europe working night or late shifts, which is also not good for circadian health because you get light when the biological system doesn't expect light if you are not shifted. And all this has short-term influences on your cognitive function, sleep deficit, social jet lag, for example, or the other already mentioned effects like sleep disorders, depression, obesity, diabetes, and cardiovascular diseases, even cancer or immune system weakening. That's why we are interested in light exposure, and in future it might be good to get something like a job exposure matrix, so you can say someone is working in this occupation and, for example, he would have or she would have had such a light exposure, and long-term health effects might be correlated with this. Moving on to what I learned from light logging and behavior and how we did it. We had, as I mentioned, I guess around 17 participants or 18, 15 colleagues from Bauer in Dortmund and Berlin participated. I participated in Berlin and in Dortmund because I was traveling on Monday, 22nd from Berlin to Dortmund. So yeah, and the other colleagues from TU Berlin participated as well. And we used lanyard and clips at the chest level. And for me personally, it was less disturbing to wear this. And I forgot also about wearing this device on this Saturday and Monday because I guess maybe because I was used to measure in millidose with this on, and it's quite disturbing to wear such a glass with a light logger. And in social contexts, it's also not so appropriate sometimes. So what did I learn from the data collection? I guess, yeah, there are quite dark nights in Germany and quite average daytime light exposure in the average of the whole data set, I guess. So not quite surprising, but we are interested in the workplace, and we found here that around 230 millilux are the median value as undiscovered by Johannes' data dashboard. And the mean value is 623. So I guess it's not so far away from the recommended level, but there's room to improve this, I guess. And in the home office especially, we have around 50 lux in median value and 160 in mean value. So there's a lot more to do in home office working places. Yeah, I personally did not change behavior, as I mentioned. I guess just one devices are the way to go, as a paper by Manuel's group some weeks ago mentioned also. And I was surprised about the great differences between mean and median values by a factor of 5 to 10 in the collected data for different settings. And I guess we have to be careful which metrics to use. And yeah, it's yeah, difficult to choose the right metric in this context. For me personally, it was also interesting to see that in long distance trains, the median and the mean value was quite close to each other. And because I work a lot in long distance trains, so mobile work seems to be not so bad in this context, but the data is very weak. 1% of the whole data was collected in long distance trains. So yeah, moving on to why it is important to measure light exposure rather than rely on perception. I guess we have talked about this in the talks before. Personally, I would say I had the right light in all these situations, but I can't measure the light. So it's very important to measure it with a device, and this device doesn't have to distract you, and else it won't be worn, like Aaron mentioned before. And also the data collection by the smartphone app might be improved because the detailed yeah, answering might be challenging. And yeah, I guess for now it works. So in future, the user experience of the research tools might be also improved. And we need to measure in the real life, in the natural environment of humans, the light exposure to draw conclusions on health outcomes in the future, because this is only the only thing we can do to get correlates and might be able to detach all the influences and to bring a context and how to say an inference between these variables. So my take-home message is from lux to health. Only by measuring personal light exposure can we design light that truly supports well-being at work. So thanks to you and to all the participants of Bauer and to you, Berlin, and especially to Lucas Bonn for support. Thank you very much.
Thank you so much, Kai. And I think shout out to you for getting so many of your colleagues to participate in a day. Like if we had a trophy, you would receive it. So our final panelist for today, it's my pleasure to welcome Andrea Sancho Salas, also my colleague, from the University of Costa Rica, who will be sharing insights into architecture.
Okay, thank you so much, Resshaya. I just want to confirm that you're seeing my screen. Yes. Well, we are really happy to hear all of these different perspectives from around the world. And I want to share one as well. My name is Andrea, and I'm an architect and a researcher at the University of Costa Rica in Central America, where I usually teach environmental design, and my main focus is daylight interpretation. Today, I would like to share how daylight behaves in this context, and how this perspective matters when we think about light and health. So, first, for me, light, I think, is more than just a contextual factor. It's also cultural and spatial experience. In the tropics, daylight is abundant. Then the way that we design our buildings, public spaces, or our daily routines, often the drivers are truly related, whether we let it in or shut it off. So that's why taking part in this global daylight initiative is so meaningful for me, because I think it enables us to compare how different societies interact with light and gives a platform to voices from the global south in a conversation that is often centered. Talking about the architecture of it, I think daylight is both actually human experience and also within. It allows us to perceive and inhabit. This relationship between architecture and light is fundamental, since we spend more than 90% of it. We start the day and end our day inside buildings, and we have to understand how the story moves around and what shapes our daily rhythms is essential for design. It provides a foundation for creating that space, and I think we need to understand our local context, solar radiation, geometric location, geographic location, sorry, and our cultural features, all of them. When we study architecture and in a specific traditional tropical architecture, we can see that it has long dealt with excessive heat and usually leading to heat shading as well. I think today's challenge is to use strategies and to find a balance between shade, flow, and daylight.
The architecture of light and how we relate to light in architecture, it's really important, right? Because we spend a lot of time indoors and we start our day and end our day inside. So I think it's important how to understand how the sun moves and also the cultural behavior that emerges around them. So Today, I think the challenge is to rethink these strategies, but also consider the non-visual effects of light and the influence on human well-being. So during this campaign, I collected data, but here in Tübingen, as I am in a research state at Manuel's laboratory. And I think it was fascinating to notice the difference between tropical and temperate light. Especially coming from Costa Rica, I can notice this difference, right? So on September 22 in Germany, it was a rainy and cloudy day, which made me realize how the sky condition affects not only data, but my own behavior, whether I wanted to be outdoor or not. Here, spaces are more enclosed during this season, and my main exposure to daylight was often through windows or while commuting. I think the sun's lower angle made the intense radiation less, as I feel it in the tropics. And also all of the layers of clothing make it harder for me to keep the light logger visible for consistent measurements. My colleagues in Costa Rica, I think they have spaces that are more open and blended between indoor and outdoor. We have terraces, we have verandas, even shaded courtyards and semi-open corridors, allowing light exposure with natural ventilation and also shade. Even though we are in a small country, all of the different variables in the built environment, the landscape, and even culturally strong characteristics shape how we experience light. So it's not just about the latitude, but also about the individual routines. I think excessive heat might keep us indoor, or even the heavy rain, but also it makes the sun or the light a little bit diffuse depending on our sky. So while measuring also melanopic illuminance during this week in Costa Rica, we saw that we were able to enjoy light in transitional spaces surrounded by nature, especially under trees. We can see that we have values above the 250 melanopic loops. That is the recommendation for healthy morning circadian exposure. And I think as an architect, this highlights how nature and architecture can provide healthy light. These in-between spaces, I think, let us receive the right light and a right time of the day. When I see the values in the spent indoor spaces, they were below thresholds. Only when we were near and well-oriented windows, or in zenithal light, we can get melanopic illuminance increase, though it also increased the heat. And finally, that makes me wonder, how can we start designing with circadian health in mind? And how can architecture and nature together help synchronize our internal clock? Also, how public policy promote health and healthy daylight spaces. I think my final message would be that interdisciplinary and global inclusion research is essential to truly understand how daylight and the built environment shape our health and our daily lives. In the end, it's not about understanding daylight also, but understanding ourselves, our rhythms, and how design can support life and well-being. So I want to thank you all for letting me be a part of this global effort and for working together in showing how daylight connects all of us.
Thank you so much, Andrea. We did it. So now I'd like to invite my co-host back to take over.
Thank you. Thank you so much, Resshaya, and thanks to all the panelists. I think really nice to see the various perspectives and interdisciplinary views here. Apologies for the slight technical issue there, but I think we solved it. What I'm going to do now is I'm going to put a couple of links in the chat. So if you folks wanted to know about the dashboard, which Johannes showed, it is openly available on an open access license. I'll put this in the chat right now. And I'd also like to invite Marina to share the illustration that she has been making throughout the panel today. So first the links.
Thank you, Manuel.
And then Marina, if you could walk us through, I think
Yeah.
whenever I looked over, it looked pretty interesting to see. So keen to
There's a
see
lot
what
of
you
things. Okay, just give me a sec and I'll share my screen. Okay. Just one more thing. Okay. Takes a little sec. There we go. Okay, so let me just recap a little bit. I'm not an expert in this field, so please just don't take it to, yeah, I'll be happy to know your details afterwards. So mainly you've been sharing about this amazing experiment you've been doing during the equinox in September with 50 people and with this new device that you've been testing. There were lots of, like from these participants, more females, and they were in very different time zones. And some of the conclusions that you share is that, well, one of the things that you were saying is that you believe that light exposure is not very well understood around the globe. So you really want to have this multidisciplinary and kind of from different locations also understanding of the light exposure. Mainly all of you were mentioning that we are very much exposed to light in the mornings and less in the evenings, and it seems like there are more benefits, and it's kind of a very big issue across the different conversations you had. And I think Spain was the winner of the most exposure a day. Yeah, and you were talking about so many different factors. Maybe I'm gonna put it a bit closer so you can see a little bit bigger what I'm talking about. So you talk about the locations, the different culture, circumstances, and that determines the behaviors, and that also is determined by the environment design. And then there's been a lot of different insights. You mentioned that light is a life regulator when you talk about neuroscience, and you find that these measures that you are creating are very valuable, and there are new insights that are very important. And you were mentioning that in many research, sometimes this is not taken in account, or in even some medical kind of measurements. And you talk about neurology and mention that it's very important. And this experiment brought a lot of awareness of our own habits, even the participants' habits, and mentioning that circadian rhythms and light exposure tends to be related also with how much daylight we have in the day and how much artificial light has in the night we are exposed to in the night, and that is related with so many different circadian kind of or rhythms and our mental health and all of that. Related with optometry, you talk about myopia and how it is also related with light exposure, and vision environmental tool, and how important it is to prevent in children there by being aware of how much light exposure they have as a prevention measure. You mentioned a lot about the awareness that this experiment brought to you, many of you. And when you talk about the circadian and sleep science, you talk about how important are all the small decisions we make, and how some decisions are under our control and some others are not. And also it's related with the right timing or the wrong timing that we are exposed to light, as we mentioned also before. And how much office work, that is seems to be a very common work we do, is not in the right rhythm for that. Also in Singapore, even though we have a lot of light around the year, there is a rapid aging population, and And you mentioned how important is the culture, behavior, and the acquisition of new habits, and how challenging also that can be, depending on the culture and the behaviors and the routines that, yeah. Then you talk about NASA performance and how pilots are not enough, like they are under very critical kind of exposure conditions, and understand what pilot experience wrong, understand what happens when we are not exposed to the right conditions. Even was very interesting for the person that actually has been measuring her own light exposure, and understand better how it impacts, no, when your circumstances are not ideal. And finally, occupational health, more related with the workplace, talking about, again, we spend too much time indoors. It's upside down, the way we are exposed to light in the morning and in the evening, and reflecting about the type of jobs and how some of them are more likely for us to have good exposure, and some of them not, and even the possibility of mobile works that seems to be even, I understood, beneficial, no? And finally, with architecture, very much highlight the factor that it's a mix of different things, culture, behavior, and architecture. And in this case, as also heat is a very important factor related with, it's not only about having light in the location, but also all these different circumstances affect, no? And they mentioned that when there was a lot of light, actually there was no way to be outside. So how to make design take in account all these different factors. And yeah, that was a lot. Thank you very much.
Thank you so much, Marina. This is really, really stunning. A really nice visual summary, I think, of everything we've heard about in the last 100 or so minutes. So fantastic to, I think, see all of this come together like this and really summarize, I think, where we stand in the field. I think we've seen that this the light exposure measurements are relevant more broadly than one field. I think there's so many disciplines that can stand to benefit from this. And I think hopefully with this event and with the data collection, we have started really something that brings us closer to, I think, optimizing light for health and well-being. We're running a little bit over time. Thank you all for joining. A big thanks to all the panelists and also my co-host Resshaya, to the audience, to you, Marina, and of course also to the Daylight Academy for running the Daylight Awareness Week. Just one slide that I would like to share, because this is just the first day, in fact, of Daylight Awareness Week. So I want to make you aware of an event that is taking place tomorrow, in which we will hear more about daylight and its impact on health, and that will be Daylight Through Children's Eyes. What role does daylight play in raising healthy, thriving children? Including Anna Biller from my group as well. So do follow and check this out. And again, thank you all for joining. And yeah, hopefully, depending on which time zone you are, you might be able to get some daylight now. For most of us, probably not. Thank you. Waiting room. It's my